Hey kiddos, in this new lesson about exponential applications, I'm going to teach you 3 different formulas so you can perfect them. So our first formula is the exponential growth or decay. This formula is, as you can see here, AT, which is the amount at time t, equals A naught, which is the initial amount, parentheses 1 plus or minus, depending if it's growing or decaying, R, which is the rate of change, parentheses, to the power of t, which is time. So we're going to do a quick problem. If you suppose the annual rate of inflation averages 3.8% over the next 10 years, the present cost of an oil change for your car is $23.95. Approximate the cost 10 years from now. So we start by substituting. So you want the amount at the time, and you start by substituting A naught. In this case, A naught is 23.95. Open your parentheses, 1 plus, since it's inflation, and then our rate is 0.038, and we change it because we're not working with percentages. You close the parentheses and you put to the power of 10 because it says 10 years from now. So after you put it in the calculator, you're gonna get as result 34.776. But we're working with dollars, so it's 34.78. And this is gonna be your answer. That's for our first formula. Our second formula, which is the half-life decay, it's kind of the same, but it's gonna the number is going to shrink. So the half-life is the amount of time it takes for half of the atoms in a sample to decay. So the A naught is the same as the initial amount, half, 0.5. The T is the time, and the K is the half-life. So in this problem, the radioactive iodide uses to test for thyroid problems has a half-life of 8 days. If you start with 20 grams of radioactive iodide, write a function of grams of iodide left after 5 days and solve. So we're going to start by substituting. We want the AT. It's going to equal 20 is our initial amount, so we write 20 here, 0.5, which is the half, and then we're going to see that the time, which is the one in the top, it's 5 days. So it's 5 on top, and we see that the half-life is 8, so we're going to write the 8 on the bottom. After we put it in our calculator, we get an answer of 12.97 grams. That's the answer of the half-life. And the last but not least formula is the compound interest. In this formula, we're going to use P, which is the principal or the initial investment, parentheses 1 plus R, which is the interest rate, over N, which is the number of times compounded per year. Close parentheses, to the power of number of times compounded per year times the time in years. So we're going to start with the problem. Write the function and find the amount that results from this investment. $1,200 invested at 4% compounded quarterly after a period of 3 years. So we're going to start AT equals 1,200, which is our initial amount,